In this segment, we'll look at Australia's renewable energy resources and how they can be developed. This is Australia's electricity grid, which is split into an eastern grid and a western grid. This shows Australia's solar resources. The strongest solar resources are in the yellow and orange areas. The problem is that the national electricity grid doesn't go there. That's unfortunate because the solar resource is huge. A solar power field 50 kilometres square could satisfy all Australia's electricity needs. A solar field 164 kilometres square could satisfy all China's electricity needs. A solar field 223 kilometres square could satisfy America's electricity needs, and a solar field 432 kilometres square could satisfy the world's electricity needs. A mirror field 1200 kilometres square, hypothetical of course, could satisfy world primary energy demand. That's a broader measure that includes electricity, transport fuel and biomass. In short, if properly harnessed, Australia's outback solar energy could power the entire world. Australia's major geothermal resources are the red areas. They're located in the same places as Australia's solar resources. The darker blue areas indicate strong wind resources. These are located in the southern half of the continent, with the strongest resources located along the southern coast. It's easy to see that overlaps exist between solar, geothermal and wind. The most notable are in northeastern South Australia and southwestern Queensland. The problem, as before, is that the electricity grid doesn't go there. And that's because Australia's electricity grid was built to service coastal coal-fired power plants. That needs to change. Connecting Queensland and South Australia would not only enhance efficiency in the existing grid, but it would open up the interior to solar, wind and geothermal energy. Furthermore, new power lines could be laid along existing natural gas pipeline rights of way. Building out such infrastructure will provide a major boost to development of large-scale renewable energy. It would put Australia firmly on a path towards lower national greenhouse gas emissions. Other areas of the continent could be developed as well. By extending the eastern electricity grid to the Great Australian Bight, large-scale wind and wave energy could be developed offshore. This could be followed by connecting the eastern and western electricity grids, enabling development of wind and solar resources on the Nullarbor Plain. By this time, say around 2030, Australia's grid will have filled out. Renewable energy will be satisfying a large part of the nation's electricity needs. At that point, the eastern grid could be connected to northwestern Australia. This would open up Western Australia's interior to solar and geothermal development. And if power lines and natural gas pipelines were laid at the same time, Australia would finally have a comprehensive continental energy generation and transmission system. Indeed, development of renewable and low-emission energy resources would be so extensive by that point, Australia may be able to generate surplus electricity. It could then export that electricity to Asia, potentially as far north as China, Japan and South Korea. All these countries already import Australian electricity in the upstream form of low-value thermal coal. Selling higher value clean electricity into these markets would create jobs, wealth and increased geopolitical influence for Australia. The key points here are: Australia has vast renewable energy resources. If it wants to, Australia can be a clean energy superpower. The key lies in expanding the electricity grid.